Hi everyone, welcome back. A very good evening to you all. Myself Ayush Tripathi, and welcome you all to this post analysis discussion of the last Job-A-Thon 45. So, before starting the discussion, just let me know if I am audible. Write a quick +1 as a confirmation from your side so that we can start the session. And how many problem you were able to solve, and also you can rate the entire contest so that we can improve it for the upcoming contest. Improve the problem set for the upcoming contest. The first two problems were relatively easy as compared to the last one, and but all the three problems were doable. The third problem was a bit tricky problem, and moreover, or I can say implementation heavy. But don't worry, we'll discuss the solution for all the three problems. So write a quick person as a confirmation in the chat box. So yeah, let's just start with the first problem. And let me change the template. This one, yes, it seems good to me. So starting with the first problem, and let me check before if I'm audible. Great. So everything seems good to me. So starting with the first problem, which was named as a count triplet, and in this problem you are given an integer array ARR, and you need to count the number of triplet of indices I, j, and k, such that I is less than j should be less than k, and the mean value of ARR of I and ARR of k should be equals to ARR of j, and we need to count the number of a triplet here. So the most important thing for this problem is the constraint. The size of the array can be up to 3000. So if you can write some solution which takes n square time, then that will also pass all the test cases. Quadratic time complexity is allowed. So with respect to this idea, let's see how we can solve this problem. So we have been given an array of a size n, and we need to count the number of triplet I, comma j, comma k, such that I is less than j and this j is less than k. And the mean value of ARR of I and ARR of j must be equals to ARR of j. So ARR of j, it should be equals to ARR of I plus ARR of k divided by 2, right? And the best thing about this problem is constraint. The value of n, that is the size of array, can be up to 3000. That is 3 multiplied by 10 power 3. So n square solution is a feasible. So how we can solve this problem? With the help of an contribution technique. So with the help of an contribution technique, what we are going to do, and not exactly the contribution technique, but some sort of a contribution technique. So here what we are going to do, we are going to just simply fix a two integer, and then we simply check for the next one, right? So what you can do, you can just simply fix ARR of j and ARR of k. Then you can check for ARR of I. Another thing that you can do, you can just simply fix the ARR of I and ARR of j, and then you can check for ARR of k. Now this would be totally up to you. So let me draw an array. So this is our array, starting with the index 0. So what you can either check for ARR of k or you can check for ARR of I, because if I fix index j and if I fix index k, then we all know what are at which range we have to check. So we have to check for the values which are for the indexes which are lesser than this j. So we need some information from the left hand side. On the other hand, if you fix j and I, so simply fix j and fix I, then what we are looking for? We are looking for some information from the right hand side. So in this way, we can solve this problem. Cool. So let's say I decided to fix j and I. I decided to fix j and I. So what will be the value for ARR of k? So ARR of k would be equals to 2 multiplied by ARR of j, which we know, and we also know the value of ARR of I. So minus ARR of I. So from the right hand side, from this right hand side, we are looking for the number of integers which are having value equals to 2 multiplied by ARR of j minus ARR of I. So this can be easily done with the help of a hash map. So one can simply use a hash map and just simply count the frequency of a desired element. So the time complexity of this solution would be n square. We iterate over all the possibility for j, all the possibility for I. So n square multiplied by log because of this map. So here I have mentioned the hash map which takes a constant time. So instead of this, let's consider the map, or in Java we can say tree map. So if we add the factor of log of n base 2, then also it will pass all the test cases. Now it's totally up to you. Either you use a hash map or a tree map. That would be totally your choice. Now coming to the implementation. So initializing the answer with 0, then taken the size of the given array, and basically this is the method that you need to complete. Then fix index j. Then here I have declared my hash map. You can also use a tree map. Just allow me 1 minute. So basically here I have hashed all the values from index j plus 1 to n minus 1, because these are the potential index for k. And then I iterate then I iterate from 0 to j minus 1. That will be the value for index I. And now you know the value that we are looking for. Yes, Gaurav, exactly. Here I have used a hash map, but what I would suggest during the contest, using a hash map is not a good idea at all, because the worst case time complexity for the hash map is linear. But in case of a tree map, it is always logarithmic. Unless until if you are not in an interview, I don't recommend anyone to go for this hash map. Anyway, now coming to the second problem. Hope it is clear to everyone. The second problem, which is named as the maximum pair. In this problem, given a string s and an integer m, here we need to form as many good pair of a character from a string s as possible. Basically, we need to maximize the number of good pair, right? And the two characters may form a good pair if either they are identical. If both the characters are same, then we can form a pair. Or the second type of operation, sum of their sky values is a multiple of m. So if any of these two conditions are true, then both the characters can form a pair. And here we need to return the maximum number of such good pairs that we can make. So for the first example, the string s, it is equals to abcd, and the value of m, it is equals to 5. So here the character a, we don't have any identical characters. So the character a, whose sky value is 97, and the character b, whose sky value is 98, they can form a pair, because their sum would be 195, and 195 is divisible by 5. So hope the problem statement is clear to everyone. Now let's see how we can solve this problem. So to solve this problem, you just only need to draw a very basic observation, which can be easily figured out by just writing some by just doing some casework. So basically we have two options. If both the characters are same, then we can form a pair, right? If we have identical character. Otherwise, if their sky value, if the sum of their sky value is a multiple of m, then also we can form a pair. So which type of operation it is useful to use first? So the operation of type 1, if s of I, if it is equals to s of j, then index I and index j can form a pair. So this is an operation of type 1, right? Then operation of type 2, if the sky value of s of I plus the sky value of s of j, if their sum is a multiple of m, then we can form a pair. As I and j can form a pair if it is a multiple of m. So my claim is that it is always helpful to use the operation of type 2 first, and then use the operation of type 1. So always give a priority to the second type of operation. Now let me give you an example for this proof. So for example, let's say we have a character A. Then let's say again we have a character A. So we all know the sky value of character A. It is 97. Then sky value of a character B, it is 98, and character C, D, E, F, G, and what next? H, and so on. So for C, it is 99, then 100, 101, then 102, 103, then 104, and so on. So let's say we have a character A, then a character again character A, then let's say we have a character, what I can say. Let's say then we have a character G. So here I have a character G, and then let's say we have a character B. So if you are going to use a operation of type 1 first, then how many pair we can form? So we can form only one pair. Just simply take these two integer, and also let's say the value of m. The value of m, let's say it is equals to 5. Let's say it is equals to 5. So here if I use the operation of type 1 first, then how many pair we can form? So let me write this as a case 1. So case 1, when you use the operation of type 1. So if you use the operation of type 1, then you can only form one pair, which is a comma a, right? You can only form one pair a comma a. We cannot form a pair g comma b because the sky value of g, it is equals to 103, and the sky value of a b, which is equals to 98. So it is equals to 201, which is not divisible by 5. Now coming to the case 2. So for the case 2, if you are going to use the operation of type 2 first, then this would be the great idea. Just simply form a pair a comma b, and the another pair a comma g. So in the first pair, the sum of their sky value would be 97 plus 98, which is equals to 195 divisible by 5. Then the second pair a comma g. So the sky value of a, it is equals to 97, and for g, it is equals to 103. So their sum would be equals to 200, which is a divisible by 5, divisible by m. So in this way, we can maximize the number of pair. So this is my general idea. Just try to use the operation of type 2 first, and then for the rest of the element, use the operation of type 1. Now rest everything is implementation after this, which is a cakewalk, not very difficult. Just simply use a hash map. Now coming to the implementation, here in my implementation, what I did, I use a two map, and in the first map, just simply iterate over the character, and for every character, check for its complementary character. For example, let's say the character is having a sky value 97. So what would be the complementary character that we are looking for? So the complementary character that we are looking for is the character with the sky value which is divisible, for which the remainder is a 3, because in this case the remainder is 2. So what is the remainder in this case? So here in this case, a 97 mod 5 mod m, it is equals to 2. So what we are looking for, the complementary value. So the complementary value that we are looking for, it is equals to 5, the value of m, minus this remainder, minus this 2, right? And then you can again take the mod, but it is not required. But it might be possible when this remainder, which is 2, can be 0. So in that case, let's take a mod. So we can take a mod with 5 again, and then it would be equals to 3. So we are looking for the character, some character for which the remainder is 3 after dividing the sky value by 5. So for example, here this A can be paired up with B, this A can be paired up with character G. Right? So we are going to look this value in my tree map or hash map, whatever it is. So here is the implementation. This is my unordered map. Again, here I have used the hash map, then initializing the answer with 0. iterate over all the indexes, and this is the value, complementary value that we are looking for. And if it is already there, then remove this from the hash map. That is, we are going to form one pair. So increment the answer by one. And otherwise, if that is not the case, we do not have other complementary value, then just simply has this character, right? And under modulus m, because it might be the complementary value for some upcoming character. And after this, now we are going to pair the rest of the values. So just simply again here I hashed all the values, right? And then we are going to take the minimum. Basically, this mini will simply store the minimum remaining value which we are left with after using the operation of type second first. So yeah, here what I did, I have taken the minimum of these two values and then simply divided by 2 because both the characters are identical. And also we decrement the value, and then we finally return this answer. The time complexity would be order of n. In case if you are using a tree map, then that would be n log of n multiplied by log of n. Now coming to the third problem, which is really very interesting. And the observation which required to solve this problem is not very hard. One can easily come up with an observation. The important thing is implementation. How you can implement the solution. So longest rearrangeable subarray with equal adjacent XOR. So in this problem, given an integer array ARR, the task is to find the length of the longest subarray such that its element can be rearranged so that the XOR of every pair of adjacent elements is equal. So we need to maximize the length of the subarray. So for the first example, we can consider any two element, that is we can pick 1 and 2, and now you can rearrange this 1 comma 2 in any order, either 2 comma 1 or 1 comma 2. It has only one adjacent pair, so the result would be same. Then you can also pick 2 comma 3, you can also pick 1 comma 3, basically any combination of two elements. Then here all the elements are identical, so we can pick all the three, and every adjacent pair has the equal XOR. So hope the problem statement is clear to you, and now let's see how we can solve this problem. So the very first thing, in which case the adjacent of the XOR of adjacent integer are same. So for example, let's say you have an array of 5 elements: A1, A2, A3, A4, and A5. So in which case the XOR of every adjacent pair is same. So one possible case that comes to your mind, when all the elements are same. Exactly, when all the elements are same, then every adjacent pair has the equal XOR, right? So what I can say, case one. All elements of the subarray are same. So for example, let's say we have a integer 7 at all the places. So in this case, every adjacent pair of element would have the same XOR, right? So what will be my answer? My answer will be the length of the array, length of the subarray, which is in this case 5. Now coming to the case 2. Is there any other case when all the adjacent pair have the same XOR? Yes. There will be only one possibility other than this, that the elements are alternating. So for example, let's say here you have element A1, then if you have element A2, then after, let me change the color here. Then let's say again element A1, then again element A2. So basically alternating. A1, A2, then A1, A2, and keep on repeating. Now this can end up with any element, either A1 or it can be ended with A2, right? So in case if you have a alternating element, then you can rearrange. Then the adjacent XOR of all the adjacent pair would be same, and this is the only case. Other than this, any possible other than this, we don't have any other case. For example, let's say you have three integers. You have a three integer a, b, and c. So in this case, definitely the XOR value of a and b, this a XOR b, not going to be not same as the XOR of b and c. So yes, we don't have any other case. So case one, when all the values are same, then we can select. And other than this, we have a case two, when the values are alternating. Now the next thing, how we can handle the case two, because handling case one is quite simple. Just simply iterate over the element and every time process the block of same element. Now the only tricky part is this case two. So now what I would suggest, just pause the video or go and try to implement it by your own. Because other than this, we don't require any other observation. Now it's totally up to you how you are going to implement the logic. In my implementation, let's see what I did. So we have an array. Let's say starting with the element 5. Let's say we have a 3 occurrence of element 5 or maybe 4. Then let's say we have a 2 occurrence of element 7. And then let's say we have a 3 occurrence of element 4. Cool. So in my implementation, what I did, I have used an array last. So last of I. So this I is an index. So this last of I will simply store the starting index of the previous element. For example, let me also write the indexes. And I'm again repeating this thing. You might have some different implementation. Now it's totally up to you. So in this case, last of 7, last of 7. So last of 4. So at index 4 we have element 7. So last of 4 will simply store index 0, right? The starting index of the previous element. The previous element was 5, so the starting index is 0. The last of the last of 5. The last of 5 will also store index 0, right? The starting index of the previous element. Do not get confused. The previous element is not 7 itself. The previous block. When I say previous element, it simply means the previous element which is not same. So 5. So again it is 0. Now in case of index 0, 1, 2, and 3, the last value would be -1. So last of 0, which would be equals to the last of 1, and up to last of 3, the last occurrence of 5. It would be equals to -1. We do not have any. I can say the index of a starting index of the previous element. So a -1 is kind of a default value. And other than this, I require one additional information. For every block, I need to keep track of a map. For every block, I need to have a map. So for example, we are going to use one map for this block, then another map, and then another map. So this is my map 1, I can say. Then this would be my map 2. The number of map would be equals to the number of blocks that we have, the block of the same element. Now what this map will store? So this map will store two information. So we all know map is a key value pair. So this will store two information. The first information is the count, what is the frequency, and then the second information would be index. So this key would be a frequency of element, and this value would be index. For example, up to which index we have the frequency 3. For example, up to at which index we have a frequency 3. So at index 2 we have a frequency 3. The frequency of 5 is 3 at index 2. So this information I will store here. At which index we have a frequency 4 for element 5. So at index 3 we have a frequency 4. So this information I'm going to store this in a map. Now how it is useful? Now let's see how it is useful. So now let me discuss with an example. After getting these two information, the value of a last and this map. So basically, I will store all the map in a vector. And let's say we have an element 7. Then let me take the same example. So let's say we have element 5. Then again element 5. Then again element 5. Then again element 5. And let's say I got element 7. So what is the length of the maximum? What is the length of the maximum subarray which is valid? So with this element is 7, which is ending at this index. So the with this index element 7, I can only select one in element 5. Now we can form a subarray with the element 5 and 7, and this is a valid. The subarray of a two element 5 and 7 is a valid. We cannot select any other occurrence of a 5, or actually we can select the two occurrence of a 5. So basically the frequency difference is one of these three, then the subarray would be valid. So in this case, what you can do, you can just simply put 5 here, then put 7, and then again put 5. So this subarray is valid. So what I noticed here. So if the frequency difference is one of these three integers, that is a -1, 0, or 1, the absolute value should be not more than 1. Then in that case, the subarray is valid. So here in this case, the frequency of the difference between frequency of 7 and 5, it is equals to 1. The absolute difference, it is equals to 1. So yes, it is valid, right? So we cannot add any other occurrence of 5. Now how I get this value? How I get this integer 3? So we all know the count up to here. So basically, let's use a variable count that will just simply store this difference. So in my implementation, I have named this variable difference as a count. So do not get confused with this thing for a future. So the value of count, it is nothing but the difference. So here in this case, the number of element 5, it is 4. The frequency of 5, it is 4, and the frequency of 7, it is 1. So 4 minus 1, which is equals to 3, right? So this difference is not allowed. So what we were looking, we are just looking to reduce the difference and make it either equals to 0 or make it equals to -1 or make it equals to 1. So the very first thing we try to make it equals to 0. So to make it equals to 0, I must have to remove 3 occurrences, right? I must have to remove the 3 occurrences of 5. And this index, the index of this element would be given by this map, right? And then I can just simply, I have this index, I have this index, so just their difference would be my answer, the length of this array, right? So this is the case when we make the difference equals to 0. Now the difference is equals to -1 is also possible, but in this case it is not possible to have the difference is equals to -1. Now let's try to make the difference is equals to 1. So in which case the difference is equals to 1. So if I subtract 2 from here, if I subtract 2 from here, then in that case the difference would be +1, which is valid, right? So just simply tell me the index at which the count is, the frequency is 2. So here the frequency is 2, right? So I have this index and I have the index of the current element. So their difference would be my answer. So this subarray is also valid, right? So this is the way how we can solve this problem. Rest everything is implementation. The idea would be same no matter what you have, in which way you have implemented. But this is my implementation. Let me just quickly summarize the complete thing. This is case 2. So if we can rearrange the element in alternating way, then it is valid. Now here I have used two information. The array last. So last of I will simply store the starting index of the previous element. And for every block, for every corresponding block, we have a map. So the map will store two things: the frequency and the index. So for example, coming to this map 2, tell me the index at which the frequency is 2. So the frequency of 7, it is 2 at index 5. So here I will store this value 5, right? And we store all the map in a vector. Now let me show you the implementation. And one another important thing, one another important case. Let's say we have another element 7, and now let's say we have element 4, right? So now in this case we need to completely discard the previous block. Now in this case I need to completely discard this block. Now this will be my first element of the subarray, right? This will be my one element, and this one is my next unique element. Now coming to the implementation, initializing the answer with 0, then taken the size of the array, and this is my vector of map vc, and this is my last array. Then I iterate over all the element. Then this is my current element, and this is map corresponding to the current block. So the frequency is 0 at index of I minus 1. It's kind of an imaginary index, not exactly imaginary, but previous one. Then initializing the count with 0, the frequency, then the current index, and if the element AR of j it is equals to the current block element, then increment the value of count, and then update the map, then copy the last from last of I and j plus plus. Then this is case 1, update the answer, and if j is less than n, then update the last value, that is a starting index of the previous element, and simply store the map, right? And update the value of I with j minus 1, because here we are again going to increment the value of I. Then again initializing I and j. This is for case 2. So I is the starting pointer and j is the current pointer. So this is for the first block. And if in my array, if we have only one block, then simply return the answer. Otherwise, this is my current map, and this is the value of count. then this is my element 1, and this one is my element 2. If we got the new element, then in that case we have to start the new block. Otherwise, update the value of count if it is one of the two element. If it is the first element, then increment it. If it is the second one, then decrement the value of count. This count is nothing but the difference between two elements, right? So this is case 1 when the difference is 0. This is case 2 when the difference is minus 1, and this is case 2 when the difference is plus 1, right? So in all the cases we update the answer, and whichever the best answer we get it at here. The time complexity would be n log of n base 2 because we are using map this time. So what I would suggest, just go and try run for some examples, then everything definitely must be clear to you. And yes, here we have seen the implementation. So yeah, these were all the solution for all the three problem, and hope you have learned something new. And thank you everyone for watching this video or attending this session, and have a good day. Good night.